Welcome to the second lesson in Chapter 2, and unlike the first lesson where we dealt with power functions, where we just had a monomial one term, these are polynomial functions, which means you're going to have multiple terms. And knowing how the equation, by just looking at it, knowing how it behaves without a calculator is so valuable. And we want you to develop those skills. And we're going to talk about several of those traits in this lesson. Some parts of the equation to identify. You have the coefficients in front of each term. The one in front is obviously referred to as the leading coefficient, and we're going to talk about that several times. You also referred to the degree of the polynomial. The degree of the polynomial is the highest degree of the whole equation. So if this was x to the fourth, this could be x to the third, x squared, x. I have lots of different x's, but the x to the fourth would be the highest, fourth degree. So I want you to recognize this form of the equation. Multiple terms. First thing I want to talk about is polynomials. Polynomial equations are continuous. No breaks. They're not piecewise functions. There are no sharp corners. They are curves. And so you need to remember that when you're looking at it. And sometimes it might just say, is the following polynomial continuous? And if it breaks, if it has a sharp corner, you would say no. Another feature is talking about the degree. And it indicates the tendency for the graph to have a specific shape. So the degree tendency, if you have, for example, an even exponent. Let's say you have x to the fourth. See that I circled the fourth, that's the fourth degree. Here you've got x to the fifth. So on one hand, one is even, one is odd. And that's important to just differentiate. I know it's simple, but if it's even, then this whole equation, that function, is going to resemble x squared. It goes back to that parabolic function. So it's like x squared. If you have an odd function, it's going to be like a cubed graph. It's going to have that snake-like function where it's low and then goes high, or may go high and then go low. So that tendency you can get right away. Then, another idea is to talk about the end behavior. You say, Ms. Reams, we already did that. Okay. When we did end behavior with the power functions, we talked about as the function approaches a negative infinity, or as it approaches positive infinity. All I'm concerned about now is the direction. Does the end behavior of the graph, the left end, the right end, are they up or are they down? Which direction is it coming or going? Is it coming from negative infinity, low, or high? And so if you have an even function, you are either going to have a positive, let's look at the leading coefficient. It could be a positive x to the fourth, it could be a negative x to the fourth. And that affects your end behavior. So if my leading coefficient is positive and it's parabolic, it's going to be just like a parabola, and their both ends are going to be up. That one's pretty easy to identify. And it would be the same with the fourth. They would both be up. But if it's negative, if that was negative x to the fourth, then both ends are down. And now this has 4 zeros. All right, it has 4 places it crosses, and we'll talk about that in a minute. And that has to do with the degree as well. But they're both negative. If the leading coefficient is negative, then both of the ends are going down. All right, we talked about if it's odd. We said that that was snake-like. So if it's a positive x to the fifth, the positive odd degree means it's the snake where it's starting low and it ends high. Starts low, ends high. Starts left down, right up. So if it's negative, it's going to be the opposite of that, right? It's going to start high and it's going to end low. Now I drew one that could have been x to the negative third. I've got 3 zeros there. It started high, came down, curved, went back down, okay? And that one looks very similar to a parabolic, but it's not if it's got a high and a low end. Then I know that it's odd. I know it has an odd exponent. Okay? So that's what we're talking about, the end behavior. I just want to know direction. So this one would be left, up, right, down. Let's talk about turning points. Turning points, let me scoot this up just a little bit. Turning points are when the graph changes from increasing and back and forth to decreasing. So it's a turning point. It's going up and then it changes and goes down, or it was down and then it changes, and then now it's going to turn and go up. So it's a turning point. This is key. At most, you can have a total of one turning point less than the degree. At most. Okay. So, for example, let's look at this function right here. This is to the 4th degree. So at most, I can have one less than that. I can have at most 3 turning points. Well, look at the graph. I've got a turning point 1, 2, 3. I have 3 turning points. Now here, that's to the 3rd degree. At most, I can have 2 turning points. Well, it's turns once there and it turns once up here in the first quadrant. The zeros, another word for zeros. Sometimes we usually use the word zeros. Sometimes you will see roots, or it may ask you for the x-intercept. It may also just say, what is the solution? All right, all of those are the same thing. Right? They're all those values where it crosses the x-axis. Okay, this is important. This has, at most, the same number as the degree. So here, at most, that was a square root, or this is a quadratic. At most, it could have 2 zeros. Well, this one just touches the x-axis, so it has 1. This is x to the 4th. At most, it can have 4 zeros, and this one does. That's to the 3rd degree. At most, it could have 3 zeros. It just has 1. Right? This is to the 3rd degree. At most, it would have just the 3 zeros. So this is where you're going to be factoring, or maybe using the quadratic formula, right? This is where you are solving for those zeros, completing the square, all those good things. Okay, we have another thing we're going to talk about, another feature. I have to go to my next page here. The next feature I want to talk about is whether the graph is going to touch or cross the x-axis. And that's important. Again, pretend you're not looking at your calculator and looking at the answer. Pretend you're just looking at the equation. And once you have found the zeros, it's helpful to know whether it's going to cross at that point or whether it's just going to touch. And the way you do that is by looking at the multiplicity. The multiplicity is the number of times a zero, remember the zeros we've already calculated, a zero appears. Okay? It's also referred to, or also noticed as the exponent of a factor. And you're either going to touch or you're going to cross. So it's going to touch, okay, if the zero has an even multiplicity. I can't spell. Need to erase that. See, I love these pens. Plicity. It crosses if the function, if the zero has an odd multiplicity. Multiplicity. Yay, got it right. Okay, and you will see this when we start doing the graphs. It becomes very apparent. Now, in class, I gave you a worksheet to use in the notes. This is what it looks like. We are going to cut this up, and when we come back, I would like you to cut this out right here, and we're going to tape it into the notes. We're just going to start this chart, and then we'll finish the rest in the second video. But let's make this example 1. We'll make this example 2. And I don't want to do the graph first. I don't want to plug it in, and I don't want to see. I want to talk about some of these things. Okay, the degree and the sign of this first function, x to the 4th plus 5x cubed plus 6x squared. Okay, it's to the 4th degree, and it's positive. This one is to the 5th degree, this equation, example 2, and it's negative. Let's talk about the end behavior. The end behavior is the limit approaches, x approaches negative infinity. Well, we talked about that a minute ago. That's the left. All right? So on the left-hand side, consequently this would be the right. All right, the left-hand side of a function that has a positive, even root, the left and the right are both doing what? They are both going up. Okay, they are both up, which means they are both going to positive infinity. Here, if I have an odd negative degree for this polynomial, that means on the left, if it's negative, that means the left side is up. Okay, remember from our graph right here, that meant it was up, and the right side is down. So this is up, and the right side was down. This goes to positive infinity, this goes to negative infinity. And we will continue the rest of this chart in part 2.